Welcome to this video on Cater's pendulum, a key physics practical experiment. We will explore how this compound pendulum is used for the high-precision determination of the acceleration due to gravity, g. The core concept of Cater's pendulum is reversibility. It uses two knife edges and adjustable weights to synchronize the period of oscillation about both points. This eliminates the need to locate the center of gravity. In this quick quiz, we review key concepts. The pendulum operates on the reversibility of centers. It's preferred over a simple pendulum because it eliminates the error in finding the center of mass. The interchangeable points are called conjugate points. Here are more quiz items. Bessel's formula accounts for slight differences in the periods. When the periods are equal, the distance between the knife edges is the equivalent length of a simple pendulum. Note that the knife edge distances must not be equal to avoid division by zero in the correction term. For material symmetry, identical sizes ensure symmetric drag, while different densities keep the center of mass off-center. Small movable slider weights adjust the periods to be nearly equal. The distance between the knife edges is measured accurately using a traveling microscope or cathetometer. Buoyancy effects reduce the calculated G value, as air reduces the effective weight. In a student lab, the most significant error comes from inaccuracies in timing the periods, as time is squared in the formula. Large amplitude swings result in slightly longer periods due to nonlinear restoring forces. Inverting the pendulum from the center of oscillation makes the original suspension point the new center of oscillation with the same period. To minimize correction error, T1 and T2 must be as close to equal as possible. Cater's pendulum is an absolute gravimeter because it measures g directly using fundamental base units. The primary purpose is to determine local g with high precision, independent of the center of gravity's exact location. It relies on the principle of reversibility. The use of different densities with identical shapes allows for symmetric drag while placing the center of gravity off-center for period adjustment. When the time periods are equal, the distance between the knife edges is the equivalent length of a simple pendulum. The center of gravity must not be exactly in the middle to prevent the denominator in Bessel's formula from becoming zero. The small slider weights fine-tune the system to equalize the time periods. It is crucial to keep the swing amplitude very small. The theoretical formulas rely on the small angle approximation. Large swings introduce nonlinearity, which increases the measured period and introduces error. Here is Bessel's working formula for g. The correction term accounts for any small difference between the periods, T1 and T2. The goal is to adjust the pendulum so T1 is approximately equal to T2, minimizing the error sensitivity to CG location inaccuracies. Thank you for watching this video on Cater's pendulum. We hope this review was helpful for your physics studies. Please like, share, and subscribe for more content on physics experiments.